Okay, so Jake and Maria are towing their friends on a toboggan. You guys know what a toboggan is? It's a little these things that you pull your kids on.
I don't have kids.
Okay, so the scenario here is this. You have a toboggan. This is a top-down view, okay? Top-down view. And we have one person pulling this way, right? And another person pulling in the opposite direction. Like this. And they're both doing this at 60 newtons. Okay, 60 newtons. So force is mass times acceleration. So it's actually, that's kilograms, with acceleration is meter per time squared. This right here we call newtons. Okay, Newton. Newton is a short way of saying kilogram times by mass divided by time squared. Okay. All right. So it says they each make an angle of 20 degrees with the line in motion. So they're like this because we're going in this direction. Right? They're sort of separate on the side and they're pulling in this direction. So with that, it's making 20 degrees each. So find the force that's pulling the toboggan forward. So visually, it's going to be this, right? And visually, the length of what we're looking for is from here to here. Okay, we want that. Okay, so most of these problems, sometimes it's better to do one way or the other, but there's two methods. The first method is to do components. The second method is using sine and cosine law. Okay, so component is the following. The concept of a component is that every vector that's not horizontal, okay, or vertical, a diagonal vector, can be thought of as sum of one horizontal vector plus one vertical vector. Isn't that true? Isn't it true that if you add this one plus this one, you get this one? Right? So instead of thinking of these vectors that's given here as 1 and 2 vector, we can think of it as combining 4 vectors. Okay, so here's what I mean by that. Okay, so this vector up here, right, there's one going this way and one going up. Again, one going this way and one going down, right? They're the exact same degrees and exact same size. So do you see that these two vectors are going in opposite direction? They will actually cancel each other out. Right? So then the sum of these two vectors will be simply the sum of this size here. Okay, this size, double this. Okay, so this is that right there we call the horizontal component of this 60 Newton vector. Okay, so if I call this vector here, let's call that vector here A. Okay, so magnitude of A. We say AX to represent the horizontal component. And using trig, the basic trig definition, you know that the AX, okay, which is this right here at the bottom, this orange part right here, AX will be 60 newtons times by cosine of 20 degrees. And we know that the vector that we're looking for, so we usually say the resultant vector, R, is just simply, right? So I guess we should use like this. Simply 2 times the x component of A. So it's 2 times 60 times by cosine of 20. So it's being pulled in the direction of 112.76 newtons. So that's method 1 through the component method. Through the sine and cosine law, using the sine and cosine law, this is what we do. We know that what we want to find is this vector here. And we know that that vector is a result of, if I call this vector A, if I call this vector B, it's a plus b. Right? And we know that this right here is 60, but so is this. We know that this is 20 degrees. Okay? And we know this is another 20 degrees, so that's 40, which means it makes this one 140. So I have to do a little bit more work here, trying to set up this triangle here. Right, so now I established a side angle side relationship. So from that I know that the resultant vector squared by cosine law is 60 squared plus 60 squared minus 2 times 60, 60, and cosine of 140. So you can see the trade-off. This one here, you have to move around your diagram a little bit more to form the triangle, so it becomes like a grade 11 problem. The other one, I actually like the other one better, the component method, because you actually break it down to more bare basics, and then you solve that instead.